Okay, in this video, we're going to work on solving inequalities. And so this one I just made up, and I'm going to walk you through the process. So the steps are always to do the distributive property, then combine like terms, and then of course we want to move our letters or variables to the left side and our numbers to the right side. And in this case, I put an equal sign, but because we're doing inequalities, it's going to be a greater than or less than, or less than or equal to basically separate our two sides. So let's first drop down our terms that we have on the left, and then do the distributive property. Okay, so again, I've taken care of the distributive property because there's no more parentheses now that I've multiplied through. So now I want to do combine like terms. Well, when I look over here on the left side, there's a negative 7x and a 4. Those are unlike terms, so I'm just going to drop those down on the left. Drop down my less than or equal to. But here I notice those are my like terms, so I'm going to drop down my 3x, and then when I do my subtraction, I get 10. So now I've taken care of combine like terms. And now I want to do letters moving to the left side so I can get x isolated and then my numbers to the right side. So I'm going to subtract. Every time you want to move a term from one side to another, you do inverse operation. So this becomes a negative 10x plus 4 less than or equal to 10. Okay, and now what we're going to do is we're going to move our numbers to the right side. Okay, so inverse operation there. Now I have negative 10x less than or equal to, this is 6. And then when I solve for x, I'm going to divide by negative 10, divide by negative 10. And now I have x. Now remember, when you divide or multiply by a negative coefficient, okay, you have to flip the sign of your inequality. And in this case, we could leave it as negative 6 over 10. However, all fractions have to be simplified and reduced. So the number that goes into both of those is 2 because they're both even. And so I get basically negative 3 over 5. And don't be confused about why I put the negative in the numerator, because it doesn't matter if you put your negative sign in the numerator or denominator. All right, so this is the answer to this problem. Like it's not on your worksheet, but I just wanted to show you if you got a fraction. We're looking for solutions that are greater than negative 3/5. All right, okay, so now let's try another one. And these are now going to come off of your worksheet. Okay, so if we look at this one, we got 3, p minus 3, okay, greater than. Okay, so again, we're going to do distributive property over here on the left. So 3p minus 9, drop down the minus 5p, drop down negative 3p minus 6. Okay, so we took care of the distributive property, where we multiply through the parentheses. Now we're going to do combine like terms. And what you notice over here on the left is these are like terms. Remember, we can separate our equation from the left side and the right side. So right here, if I do 3 minus 5, I get negative 2p minus 9 greater than, and then there's nothing for me to do on the right side. Watch my negative. Make sure you always watch your signs. So now I've done combine like terms. Now it's time to move my letters or variables to the left side and my numbers to the right side. Okay, and in this case, I'll put a greater than, so you can see that's how I'm separating my sides. Okay, so when I move a term, again, change the sign. Okay, so now I have p minus 9 greater than negative 6. And now I'm going to move my constant or number to the right side, moving it over to where it's like a term over on the other side. I do not have to flip because, again, there is no negative coefficient in front of this p. So this will just become 3. All right, so we're looking for values that are greater than, not equal to 3, but just greater than 3, which would be like 4, 5, 10, 50, right? Those are the solutions to this inequality. All right, let's see. I think that's pretty good because I've done 2 of them. So now let's do systems. Okay, now for a system of equations, remember that they give you 2 equations. So you have an equation 1, equation 2. And I'm going to show you how to determine whether you should do substitution or elimination. Okay, but you can use either method however you want, okay? All right, so in this case, I'm deciding I want to do elimination. And the reason why I want to do elimination for this one is because when I look at my y's, I notice one is a positive 2y and one is another positive 2y. So what I'm going to do is multiply, and it doesn't matter which one, but I'm going to do the bottom one. I'm multiplying this one by -1. And I'm multiplying it by -1 because when I distribute to every term in that second equation, I'm going to get negative 8x minus 2y minus 30. Okay, and the reason why I want that to happen, I'm going to bring down my equation 1, is you want for one of your coefficients to be negative and the other one to be positive so that they can eliminate, right? So I tell students just add down, right? Add everything up, and what you'll find out is this is going to eliminate and go away for 0. Combine your x's, we get negative x is equal to, and this of course is negative 6. Because we subtract, keep the sign of the bigger number. And then remember, there's no such things as negative letters in the alphabet, so we're going to make that a positive 1x, and this becomes positive 6. So there's only one answer to this system for the x coordinate, it's 6, okay? Now, you're not done, because when you have two lines, you're trying to figure out their point of intersection, so we still need the y coordinate, okay? So we're going to say since x is equal to 6, I'm going to go substitute it back into the red equations and get my y. And it doesn't matter if you use the top one or the bottom one. So 7 times 6 plus 2y equal 24. So we got, messed up there. We got 42 plus 2y equal 24. And again, we're trying to get y by itself. So we want to subtract to both sides. 2y is equal to, now if we subtract this, I want to say, I think we get 18. Let's see, 42 minus 24, 12, yep, we get a negative 18. Divide by 2 to both sides, and we get y is equal to negative 9, all right? So the point of intersection is 6 comma negative 9. That is the one solution, point of intersection, the one solution that they have in common, and where they cross and intersect. Okay, let's do another one. Okay, so now for this next one, negative 3x plus 7y. Okay, now for this one, I'm going to do elimination again. And again, how am I determining when to use elimination and when to use substitution? Because when I look at every single one of these x's and y's, I notice they all have numbers on them, right? They all have coefficients. So that tells me that I could multiply by one of the equations, or sometimes you have to multiply by a number to both of them differently to achieve that negative and positive number that I want to eliminate. So I'll show you what I mean. So I could easily say I want to get rid of my y's, and you got to think about, oh, what's their common multiple? And the answer is 35, that 35 lives in the 7 family for multiplication, 35 lives in the 5 family. But that may be a lot of work and make my numbers hard to deal with. So what I'm going to do is decide, you know what, let me eliminate x, because if I multiply the top one by a negative 3, what will happen is when I do the distributive property, I'm going to get a positive 9x. Okay, so when I multiply that negative 3 to every term, I get 9x. I get negative 21y, and then I get positive 48. You see that? So again, you're always trying to achieve, now I'm going to add down that this is what's going to eliminate, and it is okay to multiply by that negative number to make that elimination happen. Here, when I do my subtraction or my adding down, I'm in a negative 16y, and then this will become 64. Okay. Now when I divide by negative 16 to both sides, y will equal negative 4. So there's my y coordinate, okay? Now from here, we're going to go ahead and still go get the x coordinate. Remember, use the blue equations. Don't substitute back into the red, okay? So I'm going to use the top one. So I got negative 3x plus, where that y is, I'm going to put a negative 4, equal it to negative 16. And now I can figure out what x is. So this is negative 28. Negative 16. We're going to move that 28 by inverse operation to the other side, We got negative 3x is equal to, we're going to subtract. And I believe that should give us a, oh, wow. I think I should get a 9. Should I get a 9? Let me see. Oh, I'm losing it. Sorry. It's just 12. Sorry, I'm sick today. So we got 12. Oops. And then when I divide, x is negative 4. All right, sorry about that. All right, so now my point of intersection is negative 4, negative 4. All right, so this is your place of intersection with those two lines. All right, so that takes care of that. All right, now let me show you one that is substitution. For substitution, you know that you want to use it when you see one singular x or y sitting by itself somewhere. All right, so when I look at that top equation, I'm noticing that, hey, I have this y sitting there. So if I turn around and get y by itself, I would get y is equal to, I'm subtracting the negative 5 to both sides, 5x, negative 5x to both sides, and that's what I would get. Y is equal to negative 5x plus 9. So since y is equal to this expression, I can plug all this in for y in the second equation. So when I rewrite this, one thing you notice is, okay, I have all x's left in my equation, like that. So now you can solve for x. Okay, so we're again back to solving equations. We're going to do the distributive property, drop down the terms we don't need. We're doing the distributive property. And then after we do the distributive property, we're going to, so that was dp. Now we're combining like terms. So these two go together for 45x minus 63. Okay, now right here I did CLT, combine like terms. Now we're doing letters to the left, numbers to the right. So when I add that 63 over, I'm basically getting all my letters or my x to one side. And now we know we want to subtract. So 63 minus 18, we're going to borrow, make that a 13. And then 45 right here, positive. And then when we divide, x will equal 1. Okay, but again, it's a system, so we need to go get the y coordinate. So what I'm going to do is I'm going to go back to that red equation at the top and just say, okay, 5 times 1 plus y equal 9. So basically, we're going to subtract 5 away, so y equals 4. So at 1, 4, this is my point of intersection. Okay, so I hope that was helpful in showing you systems and then solving inequalities. The same methods apply for equations. And then I'll stop the video here.